All right. What's up?
Was that the thing I worked on yesterday? Because I did it on paper. I think wasn't there another thing on paper? Or maybe on
That was for the written notes. So the thing that says part 1, that was the paper. All right. So here's what's gonna happen. This document right here, if you remember when you guys open it up, it had the wrong link. Okay. So I'm just showing you this up on the screen. For your opening questions right here, if you get stuck or if there is a time that you need the answer, if you now open this assignment that says week 16, so Eli, this answers your question. Usually you can just click on the title and it takes you right to the correct place. Since you already opened the document with the wrong link, that wrong link is stuck in there. But now when you open the assignment, if you look at the bottom, the questions are there, right? So where it says presentation, that's a presentation of all the questions. So I'm telling you, on Wednesday, you're going to have an opening closing question. On Friday, you're going to have an opening closing question. And since it's Friday, what are you also going to have to do with that sheet?
Turn it in.
Okay. I'm just amazed that some of you guys treated remote learning Fridays like I wasn't even here, okay? You're still responsible for your work. All right, so what I'm going to ask you guys to do, as far as today goes, that's why there's some arts and crafts up here. I want to walk through part 1 with you. So part 1 is a video that looks really cool, but kind of needs a little bit of explanation behind it. So, and I'm sorry it doesn't get any darker, but so in this properties of matter, there's 2 things that were added last night, okay? So from where you are, if you can't see my screen and you want to watch the videos, I'm going to show you where I got them. So right now, we're going to do part 1 of this. Then we're going to spend most of class working on this properties project because it is due today. That properties project, that's why there's arts and crafts up here. I don't care if you do it on paper or electronically, but however you're going to do it, it is due today. So when you open up this assignment, it tells you that we're just going to do part 1 today. In this assignment, part 2 and part 3 are from your tech book, and part 1 is brought to you by YouTube. So these are all chemical changes that I cannot do in this room. And in fact, probably can't even be done at the high school because they involve such volatile chemicals. So when you hear the word volatile, that means they will react with anything. So is this, I don't know, did someone ask about lithium? Magnesium, lithium, all those things react so quickly that they can't be even in a high school science room where it's pretty dangerous. So this part 1 is what we're going to figure out right now, okay? So we're going to write down an observation that you see and a justification about why this is a chemical reaction, okay? So as we go through these, don't worry, none of them are going to be on a spelling test, okay? Cameron, this should be on your computer by now. Is it? Okay. Because that's my concern is that we all have this, because as I'm filling it out, you're going to be filling it out too. If you're like Cameron and can't see my screen too well, this link is what we're going to be watching. All that I ask is that if you're watching it on your screen, you turn off the volume just so there's not that weird echoey thing, okay? So, we all good? We all in the right spot? Yeah. Your name? Okay. So, we're not going to have it read to me. Oh my goodness.
Physical and chemical changes activity part 1. Observations of chemical reactions. Observing chemical reactions. While viewing the 10 most amazing chemical reactions, make an observation that explains what you are observing. Justify why what you are seeing is a chemical reaction.
So if you're ever wondering why I always have my earbud in, that's literally what I listen to 99% of the time. All right. So I will tell you, if you see people in these videos, they're probably not middle school kids. little circle, like not the white circles, what are the tiny, tiny circles popping up? Like if you look right here, right here, right here, what are they? Okay, so the chemical that you're seeing, the actual color change that you're seeing, that is from iron, right? So if you talk about what was happening to the iron in there, so for this right here, and I'll make it a little bit bigger so you can see it. So you can say the iron was chemically changed. So we can say iron was chemically changed. And if you think about a justification, think about soda. What were those little tiny circles? Carbonation. So when you say carbonation, you're not going to put carbonation. What's a simple word for that?
Carbon dioxide.
Little tiny, it begins with a B. There you go, bubbles. So anytime you see bubbles of gas, that is how you know there's a chemical reaction going on, okay? If something is bubbling, that means something else is dissolving in it that makes it kind of bubble up like that, okay? How many goes by show of hands have already heard of number 9? Okay, so do you remember where you've heard it before?
Wait, say it.
So if you've ever heard of luminol before, any kind of CSI show, crime show, you've definitely seen it before.
Yeah, I've heard that. Oh, marshmallow is- You gotta try that.
Well, yes or no, does your blood have iron in it? Yeah, so when you talk about why luminol works on your blood, it's because of the iron in it.
You gotta try this.
Well, if you've ever seen any, like, true crime show, that's what they use. And like Miss Brown was telling me earlier, like when they go to crime scenes that are like 30 and 40 years old, there's still dried blood on there. It can still detect that it's dry blood, not like dirt or something like that.
I just wanna see like the light.
All right, so for the luminol, when you talk about observations that occur, so what you're actually seeing was it did just change the color. It kind of did what in the dark?
Glows.
Glows, right? So if you talk about why it was a chemical reaction, you were making a new what?
Color?
It doesn't matter that you're making a new color.
Light.
Like, so give me like an M word, or that we talked about yesterday. There you go. So created a new molecule. All right, so for number 8, this number 8, I will tell you, they used to do in the high school, but then they had to stop because even with the strong ventilation in the high school, it was horrible. Like, it smelled horrible, it was bad, like, and it did not go anywhere.
Yo, what?
So you are chemically burning sugar. So I don't know if you've ever had the pleasure of smelling burnt sugar. Really not the pleasantest thing. So if you want to talk about exo versus endothermic, you're seeing a whole bunch of steam coming off. So does that mean it is letting out heat or keeping it in?
Letting out here.
Letting out, right? So to answer, so as far as observation, you can say the acid did what to the sugar? Burnt the sugar. And then as far as justification, if you want to talk about why, I'm just gonna, you can either put in gives off heat, or you can just write exothermic, okay? So exothermic means that it gives off heat. So the next one down, if you talk about thermite, this experiment is not done in a United States. Like, there's no way I would ever do this with anybody around. Like, there's no way this school is in the United States. I don't know why it's not getting bigger. Seriously.
Maybe popcorn?
No, so what you're looking at is like a couple thousands of degrees. So
Yeah, we did that before.
So you talk about why that's not super safe. Those kiddos, first of all, they're way too close. Second of all, were they wearing anything protective?
No.
No. So when you talk about just, like, I don't know if you've ever been in a bonfire and been hit by like a little flake, and you just go like, oh, and that's not that big of a deal. This, that's a couple thousands of degrees. If you got hit by it, it would literally just burn right through you. So the fact that it is not something that you can control, that it just kind of goes everywhere, that's what makes it so volatile, dangerous, whatever. So, is that a good example of endo or exothermic?
Exo.
Super exo, right? So for this, you can say super heated material. Just leave it at that. And then same thing, you can just copy and paste exothermic on there again. Yeah, so if you have like the more scientific thing written down, that's fine. So if you talk about other things that we're not going to do in school.
Yo.
So for those of you guys that were playing with those little molecules and you flip them around and you're like, oh, it doesn't really matter, I flipped it from one side to another. This is what happens when you do that. Something like iodine will look a different color depending on how you flip that molecule around.
Yo.
So I will tell you this, when you guys get to high school, you do have to do something called titration. And titration is kind of that same thing. Literally, you will keep on adding drops and drops and drops until it actually changes color, until that solution changes color. All right, so if you talk about what you actually observed, you can say the clear solution turned what? So the clear solution turned, you can either say colors or turn blue. If you talk about why that was happening, what was that I word?
Iodine.
There you go. So you can say iodine, changed colors. Okay. So elephant toothpaste, I won't lie, this is the #1 experiment that we usually do that last day before break. Okay. I won't lie, I'm sure the janitors are very happy that we're not doing it this year. It smells awful. It smells super awful. However, there's nothing that is very complicated in this. However, the reactant that they put in it to make it go big can be a propellant that sometimes is not safe in school. So if you look up elephant toothpaste, there's other times that people have done this reaction and it will actually like hit the ceiling because they've added a propellant to it to make it go up higher. But if you've ever done that little tiny volcano thing where you have like a little bit of baking soda and a little bit of vinegar, all of this is actually doing is an exaggerated version of it. So, if you look at that, it's giving off waves of heat. So we're going to call that exo or endothermic? Exothermic, right? But it is basically like soap suds. All you're doing is taking your little cute volcano and adding soap to it. I will tell you, it is fine for people to touch it. The only problem is, see how its colors like that? Sometimes if the dye didn't go all the way through, it ends up staining your hands pretty bad. But that's seriously like the worst that can happen to you. Like nothing in there is actually dangerous to you. So if you talk about observations that you could see, how would you describe what just happened?
Foam.
A little bit of foam or a lot of bit of
A
foam?
lot of it.
Okay, so lots of foam produced. And if you talk about what word I'm going to write, there you go. All right, so when they talk about a single replacement, this is literally when we do Stoke geometry, which is a big fancy word for just saying like balancing equations. This is one example of what that replacement looks like, where one thing is just switched with another. But you're still chemically changing it. So again, nothing complicated, you're just looking at a nail or a screw, doesn't matter, that's put in copper sulfate. You would have no reason to use copper sulfate at home, really. Like, it's not a very common thing. But I will tell you, this is a pretty neat experiment to do. So what you see can literally happen in that amount of time. So the way we usually do it in class, this is what we would have done on Monday. You literally just stick a paper clip in that copper solution, and we'll literally have those little bits of stuff on it. So when you say those little bits of stuff, what did it kind of look like? Kind of look like coral. Was it coral? No, okay. However, you're literally looking at the formation of rust. Okay. So what actually happened was stuff was like literally popping up with rust all over it. And you want to talk about how, think about why it was kind of going blah, blah, blah on the side. It was producing what?
Bubbles.
Bubbles, yeah? So bubbles of gas. So this gummy bear experiment is another one that is like super cool. We're not going to do it here. But, and this is, I would never eat the gummy bear afterwards.
Oh no, Miss Myers. You gotta hit the
So as far as things you would have, there you go. As far as things you might have seen before, this gummy bear. So this gummy bear that you're gonna see, if you've ever had like a large gummy bear, this is not a regular size. So gummy bears are mostly made out of what? No, don't say gummy. Why do they taste so good? Sugar. Yeah, so fun fact, take like a drill, it's really not that hard to empty it all over that. So you basically turn your gummy bear into a huge big volcano, more or less. Well, so if you talk about just, like if you had thrown a match at this gummy bear, it would have been out. But if you think about why that fire is continuing to burn, that sugar is helping it burn longer or shorter? A lot longer, right? Some sort of golden rain. So for this one, so if you talk about what you're actually seeing to observations, you can say volcano bear. I don't know. Volcano bear. So help me out. That was a very, what E word? Exothermic. So number two and number you can ask Anna on your list. So number 2 and number 3 are both things that we would not do in here, or even in school period. So if you talk about lead iodine is not the safest thing to have. cut.
Oddly satisfying.
So what you're seeing is all the parts that are rain, they are solid, and they're falling through a liquid solution. So as the heavier solid forms, it goes which way? Yeah, straight down, right? So when they talk about precipitates being formed, that's what a precipitate is. So for this, you can say solids fall in the solution. And then if you talk about why it's a chemical change, you are forming a new product. So when you say forming a new product, that means literally those two chemicals recombined into making two new compounds. This thing is one of the most mesmerizing. If you watch different ways of how it's done, every time this happens, it looks different.
Oh, just like there's something on the ground. They're like little snakes.
So here's the thing. However, this keeps on going and going and going.
Yeah, it takes a long time.
It looks like it's not just coming out.
Yeah. So what you're seeing is basically kind of like a spongy looking thing, but it's a little bit more solid than that. But this is not that much different than the sugar being burnt.
Tell me.
It looks like a tree.
Looks like
Yeah, well, I mean, if you talk about the fact that it can keep on going and going and going, right? You have a pile that is turning into a much more rigid solid.
Uh-oh, it's on fire.
So if help me out, what's that new word we're going to use then?
Exothermic.
This is definitely an exothermic one.
It's amazing.
But you need to appreciate the fact that it is still going and going and going. So when you talk about mercury, mercury is something that you don't want to have heat up. They are actually in a fume hood, meaning right where they are. Yep. So that is the products or the reactant still reacting even slightly after everything is done. So for this one, for the last one then, how would you describe it? The pile went what way? Upward, right? So the pile grew upward. And if you talk about what E word we're going to put, that's okay. Okay? So, what is going to happen? You guys are going to finish that on tomorrow. Okay? So, part 2 is you guys just going through some questions, and part 3 is you guys doing some vocab. Right now, I'm going to ask you to open up the other thing that was in your folder. Okay? So the very bottom thing that says Properties Project. So this thing, Properties Project, if you look up on my board, there's a lot of physical properties that you could use, right? I'm asking you, or I've given you 4: dissolvability, luster, physical state, connectivity, things like mass, color, texture. Those are also all physical properties. Volume. Those are all physical things. These are just the 4 that I picked. Chemical, there is a few more of this, like burning is on this list. Combustibility, that is on this list. So here's what's going to happen. For each one of these, like dissolvability, you're going to find a picture of it, and then give me a sentence that explains it. So, For something like dissolving, if you think about sugar, yes or no, can sugar dissolve in water?
Yes.
Yes. So literally, right here, you would just draw me a cup that has sugar water in it, and then just write a sentence that says sugar dissolves in. You guys, since you're my fourth period, Wednesday, you're going to finish part 1 and part 2. If you need help, and I'll send you an email with these 2 things, but if you need help, 8:30 to 9, I'm always there, and 1 to 2, I'm always there, with different Google Meet codes. I'm just being honest. When we come back in here on the 4th, I'm not hearing from anybody. I couldn't do this because I didn't know what I was supposed to do. I'm telling you right now, there's a ton of ways to get a hold of me, okay? So for this, when you talk about how is a candle burning, both a physical and a chemical change, if you talk about which part of this you can get back, can you get back the wick or the wax? Huh? The wax, right? The wax just does what down the sides? Melts. However, the wick is what is physically burning, right? So to answer this, we're going to start with the chemical. So you can say the wick is chemically changing. So the wick is chemically changing when it is burning. And the wax melting is a physical change. So the wick burning is a chemical change. The wax melting is a physical change.